So here we have p.6, okay, which is a little mixture of a lot of things. The primary lesson of p.6 was the cubes and the cube roots, but the homework's got old stuff on it too, and I'm going to do number 2. And, you know, we need to understand the understood. It is perfectly safe to add 0 to anything. Make the equation look like that. Now, you know, I teach Algebra 2, and we say certain things over and over and over about what students should know. But the truth is, most kids will not realize that x to the 1/3 is the cubic root of x. It doesn't matter how many times you say it, they're just somewhere else every single day. So I'm actually looking at a cubic root function, okay? Now the instruction set was to graph mom. So I'm going to graph mom first. This is mom. That's what mom looks like. For some reason my hand's a little shaky right now. Probably too much caffeine. And let's graph the child. So let's line up with our form a parentheses x minus h plus k. And from there I can get my center. Okay, the center is at 0, -5. The initial slope a is -3. Okay, so that's enough information to graph the kid. So I've got 0, -5, 2, 3, 4, 5. And my slope is -3. So I'm going to have to fall 3 more. Probably should have given myself more room. And run 1 on the left. And I'm going to have to rise 3 and run 1 on the right. And this is the kid. Now, what transformations do I see? I see, I'll type this for your sake, I see that there is a vertical shift or translation down 5. And I see that the kid is taller, right? So I see that there is a vertical stretch with a factor of 3. It's 3 times the height. It's not hard stuff. All right. The next one I'm going to do is going to be number 4, because 4 would be asked repetitively. And I don't know if I should be letting kids do this and just marking it wrong because they're not going to ask or whatever, but I'm going to do number 4. 4 requires some math, okay? And as I do this, I don't know if it's good or not, but I'm going to type, so I'm going to switch over to exponential notations, okay? So the first thing I'm going to do is I'm going to do a slight rewrite. All right. I notice that 64 and 128 are both divisible by 64. If I pull a 64 from 64x, I have an x. If I pull a 64 from 128, I have a 2. And again, I'm switching over to exponential notations because it is easier for me to type that. So I'm using the 1/2 power. That is a square root function. And then you got that plus 9 hanging around. Now, you are able to distribute that exponent to both things inside. All right? So I'm asking myself, what's the square root of 64? And I happen to know that it's 8, because 8 times 8 is 64. So -8 parentheses x minus 2 rooftopped to the 1/2 power plus 9. That's what the equation needs to look like, because for the bajillionth time, the equation needs to look like a times x minus h plus k. I keep saying that, but it ain't clicking. Y'all need to let things click. Anyways, the instruction set was to graph mom and to graph the kid. So we talk about mom. Mom contains 0, 0, 1, 1, and 4, 2. This is mom. Our kid, has its first point at positive 2, 9. So the kid's weighing up there at positive 2. And I obviously did not leave myself enough room. Now did I? Let's see if I can fix that real quick. No. Well, I can drag stuff around. That's what I'll do. Drag it the other way. Alright. You know what? Let's just scratch this. I remember what all had to be there. 3, 4, 5, 6, 7, 8, 9, 29, right up here. And we had a slope of -8. So we're going to fall 8. We're at 2, and we're going to run 1. This, boys and girls, is what the kid looks like. You know, I did not do the domain and range on the first one. I don't know what I was thinking. I was just tired. But that's what the kid looks like. All right? So let's talk about all this stuff here. Our transformations here. There is a vertical reflection. The kid is upside down. There is a vertical shift. It comes from H. Remember, H is 9, up 9. There is a vertical shift, right 2, because H was 2. And there's obviously a stretch, because this thing is a lot taller. There's a vertical stretch factor of 8. All right. Domain and range, I'll denote domain with a D. The low x value is 2 and it runs right forever until it hits infinity. The range, the low y value is -infinity because the graph shall fall forever. And if you work from right to left, you will see that it rises to a high y value of 9 with a bracket. It's not so bad. It's not so bad if you've been paying attention in class. If you haven't been paying attention in class, it's a complete disaster. All right, I'm going to leave 5 and 6 for you. I'm going to do 7, because 7 isn't something I've shown you. So, and 7 says do something first. It says factor first. And we will do stuff like this. Just, you know, breaking the bad news to you now. But to create a 4x squared, it takes a, and there's a typo. Ooh. Glad I caught that. Maybe I can fix this by the time I make homework sheets. That needs to be a 12x. To create a 4x squared, you need a 2x and a 2x. To create a 9, at least on this one, it takes a 3 and a 3. So it factors as 2x plus 3 times 2x plus 3. Now, if something is written twice, it turns out that it has been squared. So it's 2x plus 3. Quantity squared. Now, the reason I did this was to get closer and closer to my form. Now, here's where it gets fun. Okay? I am going to have to factor. So I'm going to pull the 2 from 2x. That gives me an x. I'm going to pull the 2 from 3, and you'd be surprised if that creates 3 halves. Because when we pull, we're doing division. When we do factoring, we're doing division. So we're finding the divisors. And that entire quantity is still squared. Now, as I've shown numerous times in class, we're going to distribute that 2. That exponent of 2 is going to go here, and it's going to go here. If you square a 2, you get a 4. And this is x plus 3 halves. Quantity squared. We don't do anything else with it because it's in the form now. And I know, and at this point in the year, I know who you are. I know you struggle. I did all of this because I am trying to line up with y equals a times x minus h plus k. Okay? Now, turns out a was 4. My vertex is at -3 halves and an understood number. You see how there's nothing above that k right there? 0. What do I look like? I had a square, so I look like a parabola. And again, your instruction set says draw mama and draw the kid. So mama contains 0, 0, 1, 1, and -1, +1. And this is mama. The kid has a vertex at -3 halves, which is right here. You go back 1.5 units, and it has a slope of 4. So as you run right and left one block, you rise 4. You get a pretty narrow parabola when everything's said and done. And now we move on to transformations and domain and range, obviously. The transformations here were pretty simple. It was shift left 3 halves of a unit, and vertical stretch, and we had a factor of 4 with a factor equal to 4 because it's 4 times the height. Our domain and range. The domain of any parabola is, at least any parabola in Tennessee's version of Algebra 2, is negative infinity to infinity, because we don't do the horizontal parabolas anymore, we just do the verticals. And the range of this parabola is the same as Mama because it wasn't shifted up or down. It's 0 to infinity. And that's all the homework I'm doing. I'm not doing any more. If you got questions, ask questions. Learn how to ask. Alright, so it's Friday. Hope you had a good weekend. You'll see this recording, I guess, Monday night maybe, if you watch it at all.